We are from Group DV6 in Diploma Mathematical Science, JCS 14340. Our lecturer's name is Dr. KERK. Our presentation's title is Application Linear Algebra in Traffic Flow.
Assalamualaikum. My name is Muhammad NABIL bin Muhammad NASIB. I am from JCS 14340D and my matric number is 2021814346.
Assalamualaikum and hi. My name is Muhammad FAIZ bin NORHISYAM. My matrix ID is 2021624664.
Hi, my name is FIQHLEY bin FADHAILILAMAL. My matrix ID is 2021649536.
Hi, my name is NURHANIS NAZARUDIN and my student's ID is 2021467476.
Hi, my name is BINTI ASRI with student ID 2021815824.
Introduction of the case study. First is the Gaussian elimination. Gaussian elimination, also known as row reduction, is an algorithm for solving system of linear equation. It consists of a sequence of operations performed on the corresponding matrix of coefficient. Second is the Gauss-Jordan elimination. This is an extension of Gaussian elimination. The augmented matrix is reduced to a reduced row echelon matrix R² EM. Convert back to a corresponding system of linear equation. Back substitution if needed. The third one is three types of elementary row operation ERO. First one is swapping to rows. Second is multiplying row by a non-zero number. And the third one is adding a multiple of one row to another row. Next is the fourth step of row echelon matrix REM. First is 0 rows at the bottom of the matrix. Second, each non-zero row, first entry is 1, leading 1. The row containing leading 1 is the pivot row. Third is all entries below leading 1 are 0. And fourth is consecutive row, leading 1 is to the right of the leading 1 in previous row. And lastly is the fourth step of the reduced row echelon matrix R² EM. First is 0 rows at the bottom of the matrix. Second, each non-zero row, first entry is leading 1. The row containing leading 1 is the pivot row. Third, all the entry below leading 1 are 0. And fourth, the consecutive rows leading 1 is to the right of the leading 1 in previous row.
So the purpose of study in traffic flow, when the number of vehicles increase on the road due to the rising of population that grows in Malaysia, it happens that the number of car accidents to rise as well. This results in traffic problems that causing the vehicles to line up. So first of all, by using linear algebra, it permits us to investigate traffic flow estimation using matrices and distinguish between variables with force values and those whose values can be chosen at random. We can find number of vehicles passing through a single intersection. So determine the amount of individuals that use each intersection, we use Gauss-Jordan elimination method.
Methodology. For our first example, construct a mathematical model that describes the traffic flow in the road network depicted in figure. All streets are one-way streets in the direction indicated. The units are vehicles per hour. What is the minimum possible flow that can be expected along the branch AB? So to find the answer, we have to find the augmented matrix first. To find the augmented matrix, we have to find a value of every intersection. So the flow out is equal to flow in. So for our augmented matrix, we will get the 1001, 300, 1100, 250, 0110, 100, and 0011, 150. So next, we have to use Gaussian-Jordan elimination, which is we have to use ERO. For our first ERO, we have to use negative R1 plus R2, and the value will be our new R2. Next, our second ERO is negative R2 plus with R3, and the answer will be our new R3. Next, to find the lastly, we have to use negative R3 plus R4 is equal to our new R4. And then we will get the value of our R square EM is x1 is equal to 300 minus s, x2 is equal to s minus 450, and s3 is equal to 150 minus s, while we assume our value of x4 is s. So since the distance of load must be non-negative value, we assume that the value range of S4 is from 0 until 50. So, back to the question, we have to find the minimum possible across the branch AB. So, to find the minimum possible across the AB, which is S1, we have to assume our value of S4 is the maximum value, which is 50. So, to find our S1, we will use S1 is equal to 300 minus S. So we have to substitute the value of S to the value of maximum S4, which is 50, and we will get S1 is equal to 250.
Figure represent traffic entering and leaving a roundabout junction that are very common in Malaysia. We need to find minimum flow theoretically along the branch BC and the ideal flow at that time. Units of flow are vehicles per hour. First, we need to identify the system of linear equations. We know that flow in of a junction will always equals to flow out of a junction. So from that, we can get the equation for all four junctions. Then, from that, we can form the augmented matrix. We solve the system using Gauss-Jordan elimination method, in which we will use 6 ERO steps. And at the end, we will get the reduced matrix 1, 0, 0, negative 1, 100, 0, 1, 0, negative 1, negative 100, 0, 0, 1, negative 1, 50, and 0, 0, 0, 0, 0. From the reduced matrix, we assume that x4 is t, and t is a subset of real number. Substitute t in the equations. We can get for A is x1 equals 100 plus t, for B, x2 equals negative 100 plus t, and C is x3 equals 50 plus t. Since we know from the equation for B that t cannot be less than 100, as it will result in x2 being negative, in which negative flow means traffic went the opposite ways, hence minimum possible value for t is 100. Substitute t equals 100 to other equations. At the end, we can get minimum possible value for branch BC is 0 vehicles per hour. The value of other flows at that time is 200 vehicles per hour for AB and 150 vehicles per hour for AB.
The result and discussion for question number 1 and question number 2. We use system of linear equation to analyze traffic flow by representing the flow of traffic between the 4 one-way street in question number 1 and the roundabout road junction in question number 2 as a variable. The variables that we use are x1, x2, x3, and x4. The study made certain assumptions, such as equal number of vehicles entering and leaving each intersection, and the nature of the street is one way. Based on these assumptions, the system of equation was formulated as shown. This equation were then solved analytically using the method of Gauss-Jordan elimination to find the values of traffic flow variables. By solving this equation, the study was able to determine the minimum possible flow that can be expected along branch AB in question 1, which is 50, and the minimum flow theoretically possible along the branch BC in question number 2, which is 0. So, for the conclusion, we could infer from this topic that linear algebra is crucial to our daily life, since it can be applied to engineering tasks like building roads and pavement. We can also utilize linear algebra in intersections to discover multiple people using a single junction. As a result, there is always a guarantee of safety at every intersection. We can presume that there are numerous linear algebraic techniques such as Gaussian and Gauss-Jordan elimination procedures that can be applied to particular situations in our daily life. This research also aims to demonstrate the usefulness of linear algebra in tackling the traffic flow problem that we encounter on daily basis.
Thank you for watching.